Still many students are missing. Okay, so let's start our discussion. In the first class, we have the basic ODE concept and we solved some problem. And in the previous class, we specifically checked the Euler's method and we find out how graphical solutions are drawn from numerical solution. Okay, so Euler's method is actually providing us computational values based on which the graphs are drawn. That we discussed in the previous class. So today our focus is a specific type of ODEs that we call separable ODEs. Separable ODE. So this is a unique kind of ODEs where we try to separate the X and Y. Then we'll try to solve this problem. Okay. So let's take what exactly happened in this. Then we'll take some examples to figure it out. By the way, those two screens are on. Okay. Good. Any practically useful ODEs can be reduced to the form. What is that form? That means g of y into y dash is equal to fx. If we can reduce any ODEs into this form, how? By purely applying algebraic manipulation. Just doing some algebraic calculation, we can reduce some specific ODEs or most of the practically used ODE into this categories. That is what. Okay. Then the next step, then we can integrate both sides. How? Maybe we can say with respect to x and obtained that means we have zy, that we say zy y dash is equal to fx. So this is what we have. So we can do what? We can put dx both sides because we are going to integrate both one, which is give us a constant. So what exactly happens? That means it is the zy and this y dash is nothing but the dy by dx, and here we have the dx, and here we have the fx dx plus c. So here we just try to cut this two. That means ultimately we are getting zy dy is equal to fx dx plus c. So this is what we will get. That means simply what we are doing, that whatever the ODEs we have, we just try to figure it out, which are the x and which are the y. Keep all x one side, keep all y one side. Then we are done. Right. So this is the separable. That means we separate x and y. Okay. So when any ODE can be separate, the x and y elements can be separable. You can separate x and y. That is separable ODE. Okay. If it is cannot, then that is different story. Maybe after this week, our focus will be specifically on that which are not separable. Okay. So today's class, our focus is only on separable ODE. Clear? Okay. Okay. So let's try some example to figure it out. What are the different types of separable ODE? Like different types of problem we can encounter in separable ODE. So let's begin with a very simple one. I will, let's say, the example 1. Simply I will start with y dash is equal to x. That means if I will try to solve this one, it is the most simplest one. I can just write dy by dx is equal to x. That is giving me dy is equal to x dx. I will integrate both sides, and then finally I am getting the y is equal to x square by 2 plus c. So this is my answer. This is one of the most simplest separable ODE. Right? Now, if I will try another one, let's say example 2. Again, I will try another one, little bit tricky, not so tricky actually. Y dash plus x plus 2 y square is equal to 0. This is my ODE. This is my ODE. My job is to separate x and y, and then just apply the integration to solve it. Right? How should I start? I'll just take one part in the left and one part to the other side of the equal side. That means this would be y dash is equal to minus x plus 2 y square, right? If I will try to keep the y and the x each other separate, I can write it is nothing but dy by y square is equal to x plus 2 dx. Is it making sense? Because y dash is nothing but dy by dx. So I keep the dy here. Yeah, something is missing? Yes? That's right. Yeah. I can put it anywhere. Fine? Okay. Okay. So then my job is simple. I keep all the x one side, all the y other side, and my job is just apply the integration. If I will apply the integration here, I just apply the integration. Yeah, if I will apply the integration, what will be my value? This is nothing but y minus 2 dy, right? Minus, this is my integration here, x plus 2 integration dx plus the constant. Yeah, can you tell me what is the value here, the left hand side? Yeah, I wrote it in a reasonable way so that you can easily tell me the answer. Yeah, anybody can answer me? Yes? 1/y. Yeah. And in the right side, the x square by 2 plus 2x plus 6. Right? That's my answer. It's so simple. By the way, I have one question. We have so many vacant seats here. Why you guys are sitting there? Whenever you are answering, it's difficult for me to hear. Although you can hear me because I am holding this one. But when you are speaking something, I have to read your mouth, lips. What are you saying? Okay, so next time try to sit, make this place cover and keep the back seat empty, okay? Don't worry, I'm not going to kill you. Okay, so let's try another one. Example 3. Okay. Maybe I'm not going to solve this one. I will write the question and somebody can help me to solve. Okay. Okay. So very simple one. Y dash is equal to 2 sec 2y. It's not so difficult. Is it difficult? A little bit tricky because there is no x here. Yeah. X is there with the y dash. Right? Yeah, who can answer me? I can write this one, dy by dx is equal to 2 sec 2y. If I will separate x and y, it should be cosine 2y into dy is equal to 2 dx. Are you okay with this one? If I am making any mistake, please let me know. Yeah. What is sec? 1 by cos, right? Just take it to the other side. Yeah, it's just arithmetic. Yeah, then I just integrate both sides. Cosine 2y integrating. Then it will give me what? Have you gone through the formulas I told you from the book? Anybody? Yes? Have you downloaded the book? Okay. Have you gone through the first page of the book? You found the formulas, all the integration, derivative formulas? Yeah. Okay. So tell me, cosine 2y integration is sine 2y by 2, and this one will be 2x plus 6, or I can simply make it to sine 2y is equal to 4x plus maybe another constant. I can write c1, something like that, or 2c, the both same, right? Yeah, so this is my answer. Yeah, this is a very simple problem. So I think you guys are a little bit bored with this problem. Okay, let's try something, a problem with a little bit different flavor. Okay. Okay, so if I will give the example here, example 4, y dash, carefully watch this one, is equal to y plus 9x square. Y dash is equal to y plus 9x square, and we want to solve this one. There are various ways to solve this kind of problem. Here we will take something called substitution method. We try to substitute something, the thing what we feel is a little bit tricky to solve. So if we are quite unsure how to solve this one, then we can apply a method called the substitution. That means I will try to substitute something, like what I can do is I will assume, let some variable, let's say v, is equal to y plus 9x. Okay, I will take this one. Let's v is y plus 9x. What is y plus 9x? This one, right? And then I try to derive it by taking the derivative with respect to x. So I will take dv by dx is equal to how much? dy by dx plus 9. Is it making sense? Then what I can do is I will keep the dy by dx one side, then I can write dv by dx, okay, minus 9 is equal to dy by dx, that is y dash. I will just take this positive 9 to this side. Then this is dy by dx. What is dy by dx? Y dash. Right? That means y dash is nothing but this value. Yes? Y dash is dv by dx minus 9. Yes? Yes? So I can say this y dash is nothing but dv by dx minus 9, and v is y plus 9x. Yes? So then I can rewrite this one as this is y dash, so I can rewrite this one as dv by dx minus 9 is equal to v square. Is this okay or anything wrong here? So the problem that was looking a little bit tricky or complicated, now becoming a very simple one. Right? So now what I can do is like this is dv by dx is equal to v square minus 9, and I will apply the separable method here. I will bring all the v one side and all the x the other side. Right? So then I am getting dv by v square plus 9 is equal to v square plus 9 is equal to dx. Now still v square plus 9.
Excuse me.
Why?
The minus sign goes to the right side should be plus 9.
Yeah, that's right. Plus 9, right? This one? Yeah. Sometimes mistakes happens. Yeah. And due to these mistakes, we used to lose marks in the exams. Okay, be careful. Okay. Okay, so then what to do? It still look quite complicated. Okay, so let's put something else here. Let's put something else here. Here, let's again let u is equal to v by 3, or that will give us v is equal to 3u, and then you have d equal to 3u, okay. Then what is my dv? dv
3DU.
Yeah, 3du. Or I can say dv by du is, or du by dv, right? Yeah, other way around, it is the same thing. So if I will try to put these values here in this particular one, what I will get? In place of dv, I can write 3du, and in place of v square, I can write 3u square, right? And this one is 3 square is equal to dx. Is it making sense? In place of v, I wrote 3u square, 9 is 3 square, even I can put 9 as well, okay? And what I will do is that I multiply 1, 3 here and divide 1, 3 here. So that what I can get is du by u square plus 1 is equal to dx. Here I have 1 by 3. Is it okay? Because I am trying to simplify this one into a specific form. This is 3 square, 9, 3 square 9, there's 3 into 3. So I try to cancel all the 9s. So it's 1 by 3 into du by u square plus 1. Is it making sense or anything wrong? Simple arithmetic I am applying. Or any confusion? I just skipped some step to solve this one. I didn't write each and every steps. Are you okay with this one? Yeah, please.
These are 3. You should not multiply the 3 and the 3 area because 3 to
What? Can you tell me? I divide 3 and I multiply 3. They can cancel each other, right? It's okay? It's okay? Okay. So now I can integrate, and this one, if you integrate, this is 1 over 3. What is this one? Integration du by u square plus 1. Yes, someone is saying something? Yes? Who? Yeah, please.
1 over A is tangent A over A.
That's right. That means it is tan inverse A u, right? And in the other side we have x plus c. That means if I will try to write, my u is nothing but tan 3x plus c. Yes, but this is not my answer. It is u. I should go from u to v, then v to y. But what is u? U is nothing but v by 3 is equal to tan 3x plus c. Yeah, you need to put the 3 tan 3 plus, sorry, 3x plus c. What is v? Y plus 9x is equal to 3 tan 3x plus c. Is it okay now? Or I just take the minus 9 to the other side, minus 9x to the other side. Okay, is this fine? Little bit lengthy. If any confusion, let me know. Should we move on to the next one? I'm trying to give you different flavor of the problem. Okay, so example 5. Y dash is equal to 4x square plus y square divided by xy. Yeah, again, this one is a little tricky. What to do? I can give you some hint how to start. So again, in this case, what I can do, let some variable v is equal to y by x. V is equal to y by x. That implies your y is vx, right? If your y is vx, then what is dy by dx? Yeah, here is the point. What is dy by dx? You remember what you have studied, you can answer me. Yes? Yeah, please tell. B. Is this the answer? What else? Or only this one? Huh? dvdx. Where to write? The answer is V or dvdx. Okay, you are saying dvdx. This one or dv dot dv by dx plus v or dv dx times v or what? Okay. If you remember, you must have studied something. I will tell you uv dash is equal to what? U dash v plus u v dash. Remember? You just need to apply that one here. Right? So then if we apply this one, what will be your answer? Now you can tell me the answer. Yes? V plus x dv dx. Right? So now we have what is dy by dx, this one. So if I will try to put them here in this original problem, I can now rewrite this problem as, in place of y dash I can write v plus x dv by dx, okay? And I will write this one in a tricky way so that I can help you to understand. This is x square plus y square and divided by xy. This is the original one. What I can do is I try to divide here by x square and by x square. Is it okay? Because I am dividing both in the up x square and down x square. Because they can cancel each other. Yes. That means this one is nothing but 4 plus, because this one they can cancel each other, right? Here is x and x cancel. So what I will get here? This is v square by v. Is it okay? Or any confusion? Yeah, you slowly will get familiar and you will solve them in like this. You just need some time to get familiar with this environment. Okay? Okay, so now we need to think about what this is. I can rewrite now x dv by dx is equal to 4 plus v square by v minus v. I take it to the other side, and this one is giving me how much? 4 by v. Yes? Okay, so now if I further solve this one, and I will apply now, I can apply the separable method. Try to take the x one side and the v other side. So I will have something like this. V by 4 dv is equal to dx by x. Now I am trying to figure this one, this, okay? So forget about this one because we already calculated, simplify this one. We have already solved this one. So I am trying to, this one and this one, I am trying to equate. What I did, bring this v by 4 to this side and x dx to the other side. Okay? Then I will do the integration. If I will integrate, I will get how much? Left hand side, yeah. Come on, these are simple things you should answer.
V square by 8.
That's right, v square by 8. And in the other side, so this is, you can take the 8 other side, it is v square is equal to 8 ln x plus c. But v is not our solution. Our solution should be y. So we simply write this is nothing but y square by x square is equal to 8 ln x plus c. And then my y square is nothing but 8x square ln x plus c. So this is my solution. Okay? Okay. If you are done with this one, let's try one more. Maybe example 6. And again, you have to solve this one. Sorry. Y dash is equal to sec square y. Yes. How to solve this one? I can rewrite this one as cos square y dy is equal to dx. Can I write like this? Then what is my cos square y? You just need to apply simple arithmetic. What is cos square y? One plus, yes. What is cos square y? Yes, 1 plus. Say. Y by 2. So, have you remember this one? Cos square, I can simply write cos square x is nothing but 1 plus cos 2x by 2, and sin square x is 1 minus, cos 2x by. Do you remember this thing? You just need to put here and solve it. If you put this one, if I will simply say cos square x integration dx, if you solve this one, you will get 1 by 2x plus 1 by 4 sin 2x plus c. This is a formula. It is available in that first page of your book. If you don't know the formula, you can calculate this one. You will get the same thing. Same is applicable for the sin square integration. That means the sin square x dx. If I will integrate this one, I'll get the same. X by 2 plus, no, this one is not plus, minus sin 2x by 4 plus c. So here in place of cos square y, you just need to put these values. That means if I will integrate this one here, I will integrate this one. That means how much I will get? I will get 1 y by 2 plus sin 2y by 4 is equal to x plus c. Then I can just try to rewrite it. What should be my y, or I just try to put all the y one side or the x other side. This is how we can solve it. So today we saw some problem on separable OD. So in the next class, what we do is that we will try to solve some problem based on the initial value problem as well as some application oriented problem. Okay, so that should be our plan for the next class. Okay, thank you very much guys. See you next time.
Thank you.